All right, today we're going to be looking at the mechanics of solving a larger or more complicated system. Unlike one large video that I've done before, I'm going to do a series of smaller videos for this lesson so that you can focus in on the areas that you're having more trouble with. So last time we were talking about ways we can actually solve 2x2s, which is what we did. We used substitution or we used elimination. Now we're going to take it a little bit further. So let's take a look at our first example. So when we did substitution, our general process was we chose our easiest equation, we solved it for a variable, and we plugged it into the other equation. That basic idea is still going to stay the same. So our first video here is going to be looking at the mechanics of solving a 3x3 with substitution. So let's take a look at a nice, big, scary looking example. So we're no longer going to have just two variables. Now we're going to deal with what happens if we have more. So when I talked before, I said that in order to solve a system, you have to have as many equations minimum as you do variables. So now if we have x, y, and z, we're going to need at least 3 equations to make this work. As a side note, if you write your 2's and your z's similarly, now would be a good time to actually start breaking that habit and writing them a little bit differently. Okay, so we have a system of equations. We have 3 equations, each one has an x, a y, and a z, and we have it equal to a number. This is effectively standard form for a system of equations. Notice that we have all the x's in one column, all the y's in the other, all the z's in a third. So in substitution, what we did before is we chose the easiest looking equation and we solved it for a variable. That is still our first step. We're going to choose the easiest looking equation. In this case, that looks like the first one, and we're going to solve it for a variable. I'm going to number the equations just to kind of make it a little bit easier. It does not matter what variable you solve for. Some people always prefer solving for the same one. There's nothing necessarily wrong with that. If you're used to always solving it for x because that's how you learned it in Algebra 1, you can continue doing so. It will be easier in general if we solve for the easiest looking variable. In this case, x in our first equation looks a lot easier to solve. So I'm going to take that and I'm going to solve for x. So I have x minus 2y plus z equals -4. So to solve for x, I'm going to isolate it by moving the other variables to the other side. So I'm going to add 2y to both sides, and I'm going to subtract z from each side. That gives me x is equal to -4 plus 2y minus z. So that step has still stayed the same. We chose the easiest equation, we solved for a variable. Now we're going to substitute that into each of the other equations. Since I solved equation 1, I have to substitute this into both of my other equations and work them separately. So I'm going to plug in for x in equation 2, and I'm going to substitute in for equation 3. So I have -4 times x is -4 plus 2y minus z plus y minus 2z equals 1. So I've substituted for x into my equation 2. I'm now going to simplify this into standard form, and there should only be 2 variables now, just y's and z's. So I can distribute that 4, that gives me 16 minus 8y plus 4z plus y minus 2z equals 1. Combine any like terms. So we have 16, we have a minus 7y plus 2z equals 1. And this is where it gets really easy to make mistakes. You got to pay attention as you go along. And finally, to have this in standard form, I'm going to move the 16 over. So we have -7y plus 2z equals, if I subtract 16 from each side, -15. Okay, so we did that one. We have to do it to both. So I'm going to take my x and substitute it into equation 3 now. So that's 2 times -4 plus 2y minus z plus 2y minus z equals 10. Again, we're going to simplify this down into standard form. So that's -8 plus 4y minus 2z plus 2y minus z equals 10. Combine any like terms, so we have a -8 by itself. We have a 4y plus 2y is plus 6y. We have minus 2z minus another z is minus 3z equals 10. And add our 8 to both sides, we get 6y minus 3z equals 18. Okay, making headway here. Now that we have two equations here, I'm just going to number them 4 and 5. Now that we have these equations now form a system of substitution. We can use substitution, elimination, whatever it is that we need to solve them for. Notice if there's any way you can simplify these, we should do so. So equation 5 here, all of these terms are divisible by 3. So I'm going to divide everything in that by 3 just to try to make our numbers smaller and easier to work with. So that gives me 2y minus z equals 6. Now let's mark that our equation 5 because it's a little bit easier to work with. All right, so now that we have two equations, both of these have just y's and z's in them, we have to do substitution again. So I'm going to take the easier equation, which looks like this one, and I'm going to solve that for z. So I can add z to both sides. That gives me 2y equals 6 plus z. Subtract 6, and I get 2y minus 6 equals z. Okay, we're getting there. Now that I have this, I can substitute it into our other equation that we got for z. So that gives me -7y plus 2 times. Again, I'm substituting in, so we have 2y minus 6 equals -15. And now we're finally down to a single variable. We can actually solve this. So this gives me -7y plus 4y minus 12 equals -15. Combine our like terms, that's -3y minus 12 equals -15. And we solve it for y. So it gives me -3y equals -3, y equals 1. We finally have an actual answer. Now that we've broken it all the way down to the final term, we can go ahead and plug it back in and work our way backwards. So I know y equals 1. I can plug it back into this equation to find what our z was. 2 times 1 minus 6 equals z. So that's 2 minus 6 equals z. So -4 is equal to z. Now that we know what y is and we know what z is, we can plug it all the way back in where we first solved for x. So x is equal to -4 plus 2 times our y, which was 1, minus z, which was -4. Gives me x equals -4 plus 2 plus 4, and we get x equals 2. Our final answer, since this is 3 variables, instead of being in ordered pairs, an ordered triple. So my final answer is my x value, my y value, and my z value. We have solved the entire system now. So going over the process one more time, we started with 3 equations, 3 unknowns. We chose the easiest looking one, which was the first one. We chose the easiest looking variable, and we solved for it. So I got x equals -4 plus 2y minus c. Once we had that, we have to substitute it in to both of the other equations. So I substituted it into equation 2 and simplified it down. Now we have an equation that's just y's and z's. I substituted it into equation 3, simplified it, and we have an equation in just y's and z's. This made up my equations 4 and 5. These 2 equations we can now use substitution on. So we did that. We took this equation, which was the easier one. We solved it for z, and then we substituted it into the other equation. That allowed us to finally simplify down and get our first actual number. I plugged that number back into our equation for z, solved it to find what z is, and then plugged both my y and z back into my equation for x. This is our basic process for solving this triple via substitution. So we're going to do one more example of this with substitution. Let's do, there we go. So let's do one more example, and that way we'll have the process down for substitution. All right, so let's say we have 2x plus 3y minus 2z equals -1. We have x plus 5y equals 9. We have 4z. Wow, that's a horrible eraser. We have 4z minus 5x equals 4. Okay, so notice that this isn't written in order. And we always kind of want to have things in order when we take a look at these. So I'm going to kind of mark this off as just what we started with, and I'm going to rewrite it. So our first equation here is actually our ugliest one this time. We have all three variables in it. They all have numbers and coefficients. I don't know, that one doesn't look very easy to work with. We have x plus 5y equals 9. And then we have a negative 5x plus a 4z equals 4. Okay, so this looks a little bit more straightforward. So we're going to use the same kind of process here. Our goal is still choose the easiest looking equation and then to plug it into the other two. So as I look at this one, I don't know, that second equation looks like the easiest one to me. And it's only got y's in it. So, that's going to be a little bit easier. So I'm going to start with equation 2 there. And I'm going to solve it for x. So I have x plus 5y equals 9. So I can subtract 5y from both sides. And I get x equals 9 minus 5y. Okay. We have something to work with now. Since I solved equation 2, I need to plug it into both equation 1 and equation 3 now. So that's my next step. So my equation 1 was 2x plus 3y minus 2z equals -1. Now I'm going to substitute in for x. So that's 2 times 9 minus 5y. Yeah, that's 5y. Plus 3y minus 2z equals -1. And I need to do the same thing for equation 3. Again, if we use solved for equation 2, we have to plug it into both 1 and 3. So equation 3 was -5x plus 4z equals 4. So now I'm going to plug that in for x. So I have -5 times 9 minus 5y plus 4z equals 4. Okay, each of these we now simplify to form a new system. So get 18 minus 10y plus 3y minus 2z equals -1. Combine any like terms, so that's 18 minus 7y minus 2z equals -1. And move the number over. A lot of negatives here. -7y minus 2z equals -19. Okay, now for our other one. Distribute the -5, so that's -45 plus 25y plus 4z equals 4. No like terms, so I can just move the number over. So I add 45 to both sides. I get 25y plus 4z equals 49. All right. These are kind of awful. So let's see if there's any way we can make this a little bit easier. So 1, I can multiply everything in this by -1, and I get 7y plus 2z equals 19. Okay, that's a little bit better. So there's my equation 4, here's my equation 5. Next step would be substituting one into the other. And here's a big trick that they usually don't tell you so much. When we substitute, it doesn't have to be just y. It can be something simpler or something a little more complicated. So I'm going to take this equation here, and let's say we solved it for the 4z part. If I subtracted my 25y, I could subtract 25y from both sides, and I get 4z equals 49 minus 25y. Well, notice this is 2z right here. That's almost exactly what our 4z is, right? So I could take this and make it match. I mean, we could divide everything by 4, we'll get a bunch of fractions, that's fine. There's nothing wrong with that. But anything we can do to make our life a little bit easier as we go through this process will be better. So if I multiply this by 2, I now have 4z equals something. And here's my 4z. I can directly substitute that whole thing into the other equation. So I'm going to take this whole phrase that is 4z and substitute it in. I get 14y plus, well, we know 4z is 49 minus 25y. And then we have equals 38. So I'm still substituting, I'm just doing it for 4z instead of just z. If you don't like that, you're still more than welcome to go ahead and do regular substitution at that point. We would divide this by 4, you'll get some fractions or decimals, and you can plug it right in, it'll work out fine. This just makes it a little bit easier so you don't have fractions to mess with. All right, so we combine our like terms. That gives us 49 minus 11y equals 38. Subtract 49 from both sides. We get negative 11y equals negative 11. So y is equal to 1. We finally have a number. So now we're going to work our way backwards. Since y is equal to 1, I'm going to plug it in back up here. So our 4z was equal to 49 minus 25 times our 1. So 4z equals 49 minus 25. And we get 4z equals, let's see, 49 minus 25 is 24. Divided by 4. And we have z equals 6. We've got our second one. Now we know that y is, and we know what z is. We can go all the way back up to where we first solve for x and plug in our numbers. And in this case, since there's only 2 variables, we don't even need the z at this point. We can actually plug our y directly in. So our x is 9 minus 5 times our y value is 1. So we get 9 minus 5 is 4. So we have x equals 4. We have y equals 1. We have z equals 6. My answer then is the triple 416. This is the process of solving a triple using substitution directly. So just to go back over it one more time, we start with some ugly triple set. 3 equations, 3 different variables. We line them up x's, y's, and z's in numbers. With substitution then, we choose whichever one looks easier. In this case, I thought the first one looked easier, and then we solved it for one variable. So I moved the other things to the other side, and then I simplified. So that gave us x is negative 4 plus 2y minus 7. Next step, we substituted it into both of the other equations. So I took my negative 4 plus 2y minus c and I plugged it into the second equation, and I plugged it into the third equation both. We then simplified each of these, and we got 2 new equations. This one, which I labeled 4, and this one that I labeled 5. You know you've done it right if both of these have the same 2 variables. We had y's and z's in each of them. This is just like now the problem that we did in Unit 1 where we were looking at substitution generally. So I'm going to take these 2 and choose that same process. This one looks easier. I solved it for z and I got z equals 2y minus 6. I then substituted it back into the other equation, simplified, and we got our first number, y. Once we have an actual number, we start working our way backwards through the equations that we solved. So I take my y equals 1 and I plug it back into the z value, or to find the z value. That gave me z equals -4. Once I know both of those, I plug it all the way back into what we did in that first step, and I get my x. My answer then is the x value, the y value, and the z value written as a triple. In this case, we get the triple 214. As a final note, when we talked about solving things earlier, we said there were a couple other criterion that could happen, and it can still happen here. So if you go through and you get a true statement, something like 0 equals 0, or you get 2 equals 2, that still means there's infinitely many solutions. And if you go through and you solve and you still get a false statement, somehow we get 2 equals 5 or something ridiculous, then that still means that there is no solution for the system. So keep that in mind. All right, so this is our overview of substitution for a 3x3.